On the morning of July 24, 1943, the waters stretching between Palau and Truk offered ideal hunting conditions for submarines. Standing at the periscope aboard the USS Tinosa, Lieutenant Commander Lawrence Randall Daspit watched as a shape slowly materialized from the pre-dawn mist. With each passing moment, the silhouette became increasingly distinct. What emerged was a tanker, and not just any tanker, but a massive vessel weighing approximately 19,000 tons, according to intelligence assessments. Most remarkably, she sailed completely alone. Daspit possessed enough experience as a submarine officer to recognize extraordinary fortune when it presented itself. The vessel he observed was Tonan Maru No. 3, recognized as one of the largest tankers operating within the Japanese merchant fleet. She maintained a steady course eastward at 13 knots, displaying no escort protection whatsoever, executing no zigzag defensive pattern, and implementing absolutely no protective measures of any kind. Cryptanalysts stationed in Hawaii had successfully intercepted her planned route and transmitted this vital information. Through careful positioning, Tinosa now occupied precisely the location required for a successful attack. The approach proceeded exactly as training manuals prescribed. Every calculation of geometry proved perfect. At precisely 9:28 in the morning, Daspit issued the command to commence firing. 4 Mark 14 torpedoes departed their tubes in rapid succession, their wakes carving bright white trails across the dark ocean surface. Through his periscope lens, Daspit observed them maintaining straight trajectories directly toward their intended target. The sonar operators methodically counted down the remaining seconds. Then came the unmistakable metallic impact sound. A second impact followed, then a third, and finally a fourth. 4 solid strikes registered against the tanker's hull. 4 torpedoes found their target exactly as engineering specifications promised. Yet not a single explosion occurred. The tanker began turning away, her engines accelerating to maximum power while thick smoke billowed from her stacks. Daspit uttered profanities and commanded pursuit. Throughout the following several hours, Tinosa chased the damaged vessel across Pacific waters, running surfaced on her diesel propulsion system. By the time dawn broke on July 25th, the submarine had successfully maneuvered back into an advantageous position. This time, Daspit directed his torpedo crew to meticulously inspect every weapon remaining in the tubes. They systematically verified all settings, thoroughly examined each mechanism, and confirmed that everything appeared flawless. He launched 2 additional torpedoes from a less than optimal angle off the tanker's starboard quarter. These 2 weapons struck their target. These 2 weapons detonated. The muffled rumbling sound reverberated throughout Tinosa's internal structure. The crew responded with enthusiastic cheering. The tanker's engine compartments suffered catastrophic destruction. The enormous vessel coasted to a complete halt, settling slightly toward her stern section while somehow remaining afloat. Daspit now possessed what every submarine commander fantasized about achieving. A stationary target presented itself with no protective escort, in broad daylight conditions, within clear water. He could afford to proceed methodically and establish the absolutely perfect firing solution. He positioned Tinosa approximately 875 yards from the tanker's beam, achieving a 90-degree firing angle that represented the ideal geometric relationship every submarine officer studied during training. 1 torpedo, 1 perfect opportunity. 680 pounds of Torpex explosive compound should tear the hull apart and dispatch 19,000 tons of steel and fuel oil directly to the ocean floor. At 9:30 in the morning, he issued the firing order. The torpedo maintained a straight path. The wake appeared clean and normal. The sonar operator reported standard running characteristics. Through the periscope, Daspit watched the weapon close the distance toward the motionless target. Impact occurred, producing a splash of water against the hull plating. Then nothing followed. No explosion materialized, no towering water column erupted, no crushing detonation sound occurred, absolutely nothing. The torpedo was defective. Daspit fired once more. The identical result occurred. He fired a 3rd attempt, a 4th, then a 5th. Each torpedo ran with perfect precision. Each one struck the stationary target cleanly. Each one completely failed to explode. By 10:48 in the morning, Daspit had launched 11 torpedoes at a vessel that possessed no capability to flee, no ability to maneuver, no capacity to do anything except remain positioned and await destruction. 11 confirmed impacts, 0 explosions. 1 particular torpedo struck the tanker's hull, created a splash, then inexplicably executed a right turn and leaped clear of the water surface approximately 100 feet from the stern section. Daspit subsequently wrote in his official patrol report that he found it difficult to convince himself that he had actually witnessed this occurrence. The sound of Japanese destroyer engines grew progressively louder through the sonar equipment. Assistance was approaching to aid Tonin Maru. Daspit launched 4 more torpedoes as Tinosa turned away to execute an escape. 15 torpedoes total, 13 confirmed direct hits, 2 explosions, both resulting from awkward, oblique approach angles. All the perfect shots, all the textbook approaches, all the ideal geometric solutions had produced nothing except defective duds and what would become the most frustrating patrol report any submarine commander would ever compose. Daspit made a decision that would fundamentally transform American submarine warfare operations. He preserved his 16th and final torpedo and established a course for Pearl Harbor to deliver it intact to the personnel who manufactured it. The Mark 14 torpedo was intended to represent the most advanced anti-ship weapon existing anywhere in the world. Development initiatives commenced in January 1931 with a budget allocation of $143,000. The Navy Bureau of Ordnance, collaborating with the Naval Torpedo Station located at Newport, Rhode Island, established ambitious performance specifications. This new weapon would replace the obsolete Mark 10, a World War I-era design barely capable of achieving 30 knots. The Mark 14 would reach 46 knots. It would carry a significantly larger warhead. It would incorporate a revolutionary magnetic detonation device capable of exploding beneath a ship's keel, breaking the vessel's structural backbone with a single successful strike. The torpedo measured 20 feet 6 inches in length and 21 inches in diameter. Fully loaded, it weighed over 3,000 pounds. Steam propulsion provided it with a range of 9,000 yards at high-speed settings, sufficient distance for any submarine to close with its target and fire. The price reflected its sophisticated complexity. By 1940, each Mark 14 cost upward of $10,000, representing 5 times the purchase price of a new automobile. The Naval Torpedo Station constructed these weapons with meticulous attention to detail, employing 3,000 workers across 3 operational shifts, producing approximately 1.5 torpedoes per day. However, the most critical component remained the Mark 6 exploder, a device considered so secret that its instruction manual was composed but never actually printed. The original document remained secured in a safe at Newport. Only submarine commanding officers and designated torpedo officers received information about its existence. Enlisted torpedomen who would actually handle and maintain these weapons proceeded to war without knowledge that their torpedoes contained magnetic detonation devices. The secrecy was intentional and comprehensive. The theoretical foundation behind the Mark 6 was scientifically sound. A torpedo striking a ship's hull might penetrate armor plating and explode internally, causing localized structural damage. However, a torpedo exploding beneath the keel would lift the entire ship out of the water, breaking its structural back and frequently splitting the vessel into 2 separate sections. Modern warships had developed thick armor protection and torpedo blister systems along their hulls specifically to absorb direct impact hits. The magnetic exploder would bypass all such protection by detonating in the most vulnerable location conceivable. The exploder functioned by sensing changes in Earth's magnetic field, caused by a ship's steel hull structure. As the torpedo passed beneath the target vessel, the Mark 6 would detect the magnetic signature and trigger detonation at the optimal moment. Theoretically, it was brilliant engineering. Practically, it had never been properly tested under realistic conditions. The Navy's interwar budget faced severe constraints imposed by congressional funding reductions. Testing procedures were expensive. The Bureau of Ordnance convinced itself that at $10,000 each, Mark 14 torpedoes were simply too expensive to destroy in live fire testing scenarios. When Chief of Naval Operations William Pratt offered the hulk of destroyer USS Erickson as a test target, he prohibited using a live warhead and insisted that Bureau of Ordnance pay to refloat the ship if it was accidentally struck during testing. Erickson was already scheduled for scrapping anyway. The restrictions made no practical sense whatsoever. Bureau of Ordnance declined the offer. Instead, testing relied exclusively on exercise warheads filled with water. The torpedoes were fired to run beneath target vessels with recovery and subsequent examination afterward. If the torpedo passed under the target ship successfully, Newport Torpedo Station assumed the magnetic exploder would have functioned as designed. No personnel ever tested a Mark 14 with a live warhead against an actual ship hull. No one fired the weapon under combat conditions. no one verified that the depth control mechanism would function correctly with the heavier operational warhead. Congress had made Newport the sole designer, developer, builder, and tester of American torpedoes. In 1923, there existed no independent verification process, no competing facility to check the results, no oversight beyond Bureau of Ordnance's own confidence in its engineering capabilities. The submarine force possessed no input in the weapons design process. The testing was inadequate by any reasonable standard. However, when war arrived at Pearl Harbor on December 7, 1941, and Admiral Chester Nimitz ordered unrestricted submarine warfare against all Japanese shipping, American submarines proceeded to war carrying Mark 14 torpedoes in their tubes. Within 1 week, the first problem reports began arriving at headquarters locations. The United States Navy submarine force in 1941 was not a unified command structure. Unlike naval aviation, which possessed its own dedicated bureau in Washington and a clear chain of command, submarines operated under a fragmented organizational structure that would prove disastrous when technical problems emerged. 3 separate submarine commands existed simultaneously. Commander Submarines Pacific Fleet operated from Pearl Harbor. Commander Submarines Southwest Pacific worked from Australia. Commander Submarines Atlantic Fleet covered the eastern seaboard and the Atlantic Ocean. Each commander reported to his regional fleet commander. None possessed direct authority over the others. There was no central submarine commander in Washington to coordinate operations, share information, or speak for the entire submarine community. This fractured command structure meant that when submarine skippers began reporting torpedo failures in December 1941, their complaints went to different people in different places who had no mechanism to compare notes or recognize patterns. USS Seawolf filed a report on December 14th, barely 1 week after Pearl Harbor, stating that Mark 14 torpedoes were running deeper than their depth settings indicated. USS Sargo reported on Christmas Eve that 8 torpedoes fired at a Japanese transport near the Philippines had struck the target, but not one had exploded. Other commanders reported similar experiences involving torpedoes running too deep. Premature explosions, duds, and magnetic exploders that seemed to detonate randomly, sometimes before reaching the target, sometimes not at all. The Bureau of Ordnance response to these reports was consistent and unwavering. There was nothing wrong with the torpedoes. The problems were caused by faulty tactics, inadequate training, poor maintenance procedures, or incorrect procedures executed by submarine crews. When USS Skipjack's commander reported depth control issues and requested permission to conduct field tests, Bureau of Ordnance sent an expert to investigate. This expert examined the submarine's remaining torpedoes, reviewed crew procedures, and submitted a report placing all blame on the crew. He found nothing wrong with the weapons themselves. This position was not simply bureaucratic stubbornness. The naval bureaus of 1942 operated with extraordinary autonomy. Not even Admiral Ernest King, who held the unprecedented combined position of Commander-in-Chief United States Fleet and Chief of Naval Operations, had direct authority over Bureau of Ordnance. As one submarine commander later explained, a naval officer conditioned to believe the Bureau's word was infallible in matters of ordnance did not lightly challenge it. The institutional culture of the Navy discouraged questioning weapons that had been developed, tested, and certified by the service's own experts. Bureau of Ordnance's confidence in the Mark 14 had some basis in their own experience. The torpedo had passed all their tests at Newport. The magnetic exploder had been evaluated in equatorial waters by USS Indianapolis, which fired 100 trial shots and collected 7,000 readings. The depth control mechanism had been verified using standard testing procedures. Everything checked out on paper. The problem was that those tests bore little resemblance to combat conditions. Exercise warheads were lighter than live warheads. Test firings aimed to have torpedoes run under targets, not hit them. The magnetic exploder sensitivity had been calibrated at Newport's latitude, but never verified across the various magnetic fields that existed throughout the Pacific Ocean. By mid-1942, American submarines in the Pacific had fired over 800 Mark 14 torpedoes in combat. 80% had failed, but at Pearl Harbor, Commander Submarines Pacific Fleet, Admiral Robert English, consistently sided with Bureau of Ordnance and blamed his submarine skippers for their lack of initiative. When commanders requested permission to disable the magnetic exploders and use only contact detonation, English refused. citing torpedo shortages from inadequate production at Newport Torpedo Station. His submariners responded by disabling the magnetic exploders anyway, doctoring their patrol reports, and overstating the size of enemy ships to justify using more torpedoes than officially authorized. The system was breaking down, but one officer was listening to his submarine commanders, and he was willing to risk his career to prove they were right. Rear Admiral Charles Andrews Lockwood was not a typical flag officer. He had begun his submarine career in 1914 aboard A2, the Navy's second submarine. He had commanded Submarine Division 1 in the Asiatic Fleet during World War I. Between the wars, he had held virtually every submarine command available. In February 1941, he served as naval attaché in London, where he debriefed the American pilot who had helped sink the Bismarck. In May 1942, he became Commander Submarine's Southwest Pacific area based in Fremantle, Australia. His reputation among submarine officers was exceptional. They called him Uncle Charlie, a nickname that indicated respect and affection in equal measure. Admirals earned that kind of nickname when they listened to their subordinates and took action on their behalf. In June 1942, after months of receiving identical failure reports from every submarine under his command, Lockwood made a decision that would define his career. He ordered field tests of the Mark 14 torpedo without explicit approval from Bureau of Ordnance. This was not a small act of insubordination. It was a career-ending risk for an officer who was directly challenging the Navy's premier weapons development bureau. Lockwood understood the stakes. He also understood that his submariners were dying because their weapons didn't work. The test site was Frenchman Bay at Albany, Australia in King George Sound. On June 20th, 1942, USS Skipjack took position at a range of 850 yards from a fishing net rigged vertically in the water. Commander James Coe fired a single Mark 14 torpedo with an exercise warhead set for a depth of 10 feet. The torpedo ran straight and true. It struck the net cleanly. The hole it tore through the netting was at 25 feet depth, 15 feet deeper than the setting. The test was repeated. Same result occurred. Commander James Fife, Lockwood's Chief of Staff, supervised additional test shots the following day. 3 torpedoes set at 10 feet cut the net at an average depth of 21 feet, 11 feet deeper than their settings. Lockwood reported his findings to Bureau of Ordnance. The response came back swiftly. No reliable conclusions could be drawn from these tests. The Bureau questioned the test methodology, the accuracy of the measurements, and the competence of the personnel conducting the tests. Lockwood repeated the entire test series with another submarine. The results were identical. Torpedoes were running approximately 11 feet deeper than their depth settings. This was not operator error. This was not faulty tactics. This was a fundamental design flaw in the Navy's primary submarine weapon. Admiral Ernest King, Commander-in-Chief of the United States Fleet, learned of Lockwood's tests in July 1942. King, himself a former submarine officer, ordered Bureau of Ordnance to conduct their own verification tests immediately. One officer later described King as having lit a blowtorch under the Bureau of Ordnance. On August 1st, 1942, after conducting tests at Newport, Bureau of Ordnance formally conceded that the Mark 14 torpedo ran 10 feet deeper than set. 6 weeks later, they admitted in writing that the depth control mechanism had been improperly designed and tested. 8 months into the war, the Navy's premier weapons bureau acknowledged what submarine commanders had been reporting since December 7, 1941. The problem had multiple causes. The torpedo had been tested using exercise warheads filled with water. Live warheads contained Torpex explosive, which was significantly heavier. The additional weight caused the torpedo to sink deeper during its run. Additionally, when engineers increased the warhead size during development, they moved the depth control pressure sensor from the torpedo's nose to a location near the tail. As the torpedo moved through water at 46 knots, the pressure differential at the tail location was lower than at the nose. The sensor interpreted this lower pressure as being too shallow, so the torpedo automatically adjusted to run deeper. These were basic engineering errors that proper testing would have revealed, but proper testing had never been conducted. The Mark 14 had gone to war with a depth control system that was fundamentally flawed. Submarine commanders now had official authorization to adjust their depth settings by 10 feet to compensate. The problem was solved, except it wasn't. Correcting the depth control problem should have increased the number of Japanese ships being sunk. Instead, submarine commanders reported a different issue becoming more prominent: premature explosions, torpedoes detonating before reaching their targets. Some exploded hundreds of yards away from enemy ships. Others detonated so close to the intended target that submarine commanders initially reported them as hits, only to watch through their periscopes as undamaged vessels continued steaming away. The magnetic exploder was the culprit, but understanding why it failed required understanding something Bureau of Ordnance had never properly tested. Earth's magnetic field varies significantly depending on location. The Mark 6 exploder had been calibrated and tested near Newport, Rhode Island, at approximately 41 degrees north latitude. It had received limited testing in equatorial waters when USS Indianapolis fired 100 trial shots between 10 degrees north and 10 degrees south latitude. But the vast Pacific Ocean, where American submarines were actually fighting, covered latitudes from approximately 40 degrees north near the Aleutian Islands to 40 degrees south near New Zealand. The magnetic field strength, orientation, and characteristics differed dramatically across this enormous area. Japanese ships built with ferrous steel created their own magnetic signatures that interacted unpredictably with the local magnetic field. The Mark 6 exploder, designed with rigid sensitivity settings, responded to these magnetic variations in ways its designers had never anticipated. Sometimes it detonated too early. Sometimes it failed to detonate at all. Sometimes it worked exactly as designed. The unreliability was maddening. A submarine commander could fire 4 torpedoes at the same target under identical conditions and get 4 different results. Reports flooded into submarine headquarters throughout early 1943. On April 10th, USS Pompon fired 6 torpedoes at Japanese aircraft carrier Shokaku. At least 3 exploded prematurely. The carrier escaped undamaged. On April 10th, 1943, Bureau of Ordnance Chief Admiral William Blandy wrote to Lockwood acknowledging that the Mark 14 was likely to explode prematurely at shallow depths. Blandy recommended disabling the magnetic influence feature if torpedoes were fired for contact hits. The admission was significant but incomplete. Bureau of Ordnance also concluded that the Mark 6 magnetic exploder was less effective below 30 degrees north latitude and did not recommend its use below 30 degrees south latitude. This effectively meant the magnetic exploder couldn't be trusted in most of the Pacific combat zone. At Pearl Harbor, despite nearly unanimous suspicions from submarine commanders, Admiral Thomas Withers refused to authorize deactivating the magnetic exploder. His reasoning was purely logistical. Torpedo production at Newport Torpedo Station could barely keep pace with demand. Withers argued that shortages made it impossible to waste torpedoes by using only contact detonation, which historically required more hits to sink a ship than magnetic detonation beneath the keel. His submarine commanders responded by taking matters into their own hands. They disabled the magnetic exploders without authorization. They doctored their patrol reports. They overstated the tonnage of ships they attacked to justify using more torpedoes than officially allocated. The system of trust between submarine crews and their headquarters was disintegrating. In May 1943, the most famous submarine commander in the Pacific Fleet returned from patrol, having failed to inflict any damage despite multiple attacks. Lieutenant Commander Dudley Walker Morton, known throughout the submarine force as Mush Morton, had a reputation for aggressive tactics and spectacular success. His previous patrols had made him a legend among submariners. When Morton reported total failure due to torpedo problems, Lockwood finally had the evidence he needed. If Mush Morton couldn't make the Mark 14 work, the problem wasn't the submarine commanders, it was the weapon. Lockwood requested permission from Admiral Chester Nimitz to deactivate the magnetic exploders on all submarines under Pacific Fleet command. On June 24, 1943, Nimitz issued the order. All Pacific Fleet submarines would disable the Mark 6 magnetic influence feature and rely solely on contact detonation. 18 months into the war, American submarines were finally authorized to bypass half of their torpedoes' exploder mechanism. But Rear Admiral Ralph Waldo Christie, commanding submarines in the Southwest Pacific area, refused to comply. Christie had spent years at Bureau of Ordnance. He had led the team that developed the Mark 6 exploder. He had personally proposed testing the device at different latitudes to verify its performance across varying magnetic fields. The magnetic exploder was his creation, and he maintained absolute faith in its design. When Nimitz ordered Pacific Fleet submarines to disable the magnetic feature, that order did not apply to Christie's command in Australia. Christie operated under General Douglas MacArthur's Southwest Pacific Command structure, not Nimitz's Pacific Fleet. He issued strict standing orders that no part of the Mark VI would be disabled or modified. Submarines that began their patrols from Pearl Harbor and ended them in Fremantle or vice versa had to navigate conflicting orders about their own weapons. This was the situation on July 7th, 1943, when USS Tinosa departed Midway for her second war patrol. Lieutenant Commander Daspit commanded a submarine equipped with Mark 14 torpedoes that had disabled magnetic exploders in accordance with Pacific Fleet orders. When he encountered Tona Maru No. 3 on July 24th, his torpedoes were set to use only contact detonation. The first 4 torpedoes that struck without exploding could not be blamed on magnetic exploder problems. Those devices were disabled. The 2 torpedoes that did explode, fired from awkward angles, suggested something was wrong with the contact exploder itself. The 13 subsequent hits that produced no explosions confirmed it. Daspit arrived at Pearl Harbor on August 4, 1943. He proceeded directly to the submarine piers where Rear Admiral Lockwood waited. Lockwood later wrote about that meeting in his memoirs. He expected a torrent of profanity, damning him, the Bureau of Ordnance, the Newport Torpedo Station, and the base torpedo shop. He couldn't have blamed him. 19,000-ton tankers don't grow on trees. He thought Daspit was so furious as to be practically speechless. Daspit delivered his patrol report. 15 torpedoes fired, 13 confirmed hits at point-blank range from perfect firing angles, 2 explosions, both from oblique approaches. The remaining torpedo, number 16, sat in Tinosa's tube. Daspit had saved it specifically for examination. The torpedo was removed and delivered to the base torpedo shop. Technicians examined every component. They found nothing wrong. Every mechanism functioned exactly as designed. The torpedo was in perfect working order. This was the proof Lockwood needed. But it also presented a deeper problem. If the torpedo was mechanically sound, if the magnetic exploder was disabled, if the depth setting was correct, why had 13 direct hits at a stationary target produced 13 duds? There had to be a third major defect in the Mark 14. Something wrong with the contact exploder itself. Lockwood called in Commander Charles Mommsen, known throughout the submarine force as Swede Mommsen. Mommsen commanded Submarine Squadron 2 at Pearl Harbor. He was one of the Navy's most innovative submarine engineers. He had invented the Mommsen lung, a portable breathing device that had saved hundreds of submariners from sunken submarines. He had developed the submarine rescue chamber used throughout the fleet. In 1939, he had supervised the rescue of USS Squallus's crew after that submarine sank off Portsmouth. New Hampshire Mommsen's habit of speaking his mind and challenging official doctrine had earned him few friends in the Pentagon, but it made him exactly the officer Lockwood needed. Mommsen organized a test that would finally reveal the contact exploder's fatal flaw. He worked with Lieutenant Commander Art Taylor, the gunnery and torpedo officer for Commander Submarine's Pacific Fleet. Beginning on August 31, 1943, they fired live Mark 14 torpedoes with warheads attached directly into the submerged cliffs of Kahulawe Island. The torpedoes struck solid rock at 46 knots, simulating perfect perpendicular hits against enemy ship hulls. Some torpedoes exploded, others were recovered. The directive establishing permanent policy requiring realistic testing before adopting any torpedo device as standard should have been obvious from the beginning. The fact that it took 18 months of war and thousands of combat failures to establish this policy revealed how far removed Bureau of Ordnance had been from combat reality. Testing with exercise warheads under peacetime conditions bore no resemblance to firing live warheads at enemy ships under combat conditions, but this apparently hadn't occurred to anyone at Newport or Bureau of Ordnance. The Mark 14 torpedo scandal provides enduring lessons about organizational failure, institutional resistance to evidence, and the critical importance of realistic testing. When organizations develop weapons in isolation without input from personnel who will use them in combat, failures are inevitable. When testing procedures prioritize cost savings over realistic simulation of combat conditions, defects will remain hidden until people die. When institutional pride prevents acknowledging mistakes, problems persist until forced into the open by undeniable evidence. When command structures fragment authority and prevent information sharing, patterns remain unrecognized. and systemic problems appear as isolated incidents. When secrecy prevents the personnel maintaining equipment from understanding how it functions, troubleshooting becomes impossible. When budget constraints become excuses for inadequate testing, the true cost is paid in blood during wartime. The officers who challenge this system risk their careers to do so. Lockwood conducting unauthorized tests, Mommsen organizing realistic impact tests, Daspit preserving evidence instead of using his final torpedo, Morton reporting failure despite his reputation. Each of these men recognized that following procedures and protecting careers was less important than fixing weapons that didn't work, and saving the lives of submariners who depended on those weapons. Their actions represented the best traditions of military service: devotion to mission accomplishment and welfare of personnel over institutional interests and personal advancement. They were willing to challenge authority when authority was wrong, to question expertise when expertise was mistaken, to pursue truth when truth was unwelcome. The submarine force needed more officers like them. The Navy needed more officers like them. Every military service needs officers like them. The 19,000-ton tanker Tonen Maru No. 3 sailing away from Tinosa, damaged but afloat, represents every target that should have been destroyed but escaped. The 13 perfect shots that produced 13 failures represent every submariner who did everything correctly and got nothing in return except frustration and danger. The 18 months of denial represent every organization that prioritizes protecting its reputation over acknowledging mistakes and fixing problems. The story ends with functional torpedoes finally reaching submarines in late 1943, enabling them to conduct the devastating campaign against Japanese shipping that strangled the Japanese war effort. But the story should have ended differently. It should have ended with properly tested weapons issued from the beginning, with realistic evaluation preventing defects from reaching combat, with institutional processes that welcomed reports of problems rather than dismissed them. The cost of the actual outcome, measured in lives lost, opportunities missed, and time wasted, can never be fully calculated. But it can be studied, understood, and remembered as a cautionary tale about what happens when organizations fail the people who depend on them. The submarine force learned these lessons the hard way. Future generations inherited the responsibility to ensure they are never forgotten and never repeated. The memorial to this failure is not a monument, but a commitment to realistic testing, honest evaluation, and willingness to challenge authority when evidence demands it. This is the complete story of the Mark 14 torpedo scandal, told without embellishment or dramatization beyond what the historical record provides. The facts alone are sufficiently dramatic, the institutional failures are sufficiently damning, the courage of the officers who force change is sufficiently inspiring. Nothing needs to be added or invented to make this story meaningful. It stands as historical truth, documented in patrol reports and official memoranda and post-war analysis, a permanent reminder of what can go wrong when bureaucracy overrides reality and what can go right when individuals have the courage to challenge systems that fail.